this is your last topic. Kirchhoff's laws. Now, when we see these circuits which are comprising of what you call rheostats, lot of rheostats, resistors, and they're arranged in series and parallel, we used to combine them, right? Like what is the effective resistance and all. The circuits may not be that simple also. So a circuit may have one EMF source, two EMF sources, then there may be a couple of resistors, there may be capacitors and all. So Kirchhoff's laws are very useful. These are the first networking laws which help you understand how to calculate current and voltages, or how to calculate current and EMF, what is the potential drop in a circuit. So these laws are used to solve complex circuits. Okay, Kirchhoff's laws, before understanding, let's understand two concepts called node versus junction. Node, junction and loop. Let us understand these three things, typically in English language. Well, a node is something when two wires join together, that is called a node. So what is a node? Two wires joining together, so two wires joining together, let's say the joining has happened here. This will be known as a node. Is that clear? Whenever three wires are joining, then this is known as a junction. This is a junction. Absolutely easy and very interesting. And then comes something called loop. Loop is a part of a circuit. Like, I don't know, wherever you go, end of the day, you have to come back. You have to come back from where you started. And we will dive more into loop. A loop is something like this. Okay, children, this is say A, B, C, D. So how do you go in a loop? You can start from any node. A loop is going to have nodes. There may be many nodes. So don't think like a circuit. Just think like a geometric figure. From node A you started. You can go in this manner or you can go in this manner. Clockwise or anti-clockwise. Come back to the same place from where you started. And if you are able to come back to the same place, you are actually traversing a loop. So is the concept of loop understood? Right. A loop in this chapter of ours, a loop will have many components like resistors and other things inbuilt in between them. Clear? Also, the loop may have loop within a loop is also possible, bacha. Okay. So like this is X, this is Y. So you see there's a junction formation here. This is a junction. So I can come A, X, Y, D, A, B, C, D, A, X, B, C, Y, X. These are all known as loops. Have we understood? Okay. So Kirchhoff's laws are actually comprises of two laws. The first law is known as the current law. Current law or the current rule. Kirchhoff's laws or Kirchhoff's rules, laws. Okay. Current rule or law. Many people will call this as the KCL, Kirchhoff's current law. Current rule, also known as the junction rule. Junction rule. Okay. Junction rule says what? Think it like water. This is for current. Current is analogous to water in plumbing. The water that entered your house has to leave your house. Have you understood? Water that enters your house has to leave your house because this is called the law of conservation of water. You can't destroy water, you can't create water. Whatever water entered has to go out. So let us take one junction, okay? And then your understanding will be very easy. This is one junction. And let's say I have a current I1 and I have a current I2, both of which are flowing towards this junction. And this current is say I3. So if you look at this junction, the law says that the current entering, okay, current entering should be the current leaving. So I would say sum of current entering should be sum of current leaving. Leaving what? A junction. Somebody will write Book's definition also, which are correct. At any junction, the algebraic sum of current entering and leaving it is taken to be 0. If entering current is taken as positive, exiting current will be taken as negative, right? So the algebraic sum of currents entering and leaving a circuit is 0. Otherwise, you can say the total current entering a circuit is the total current that leaves a circuit. So from this, what all we can write? We can write an I1 plus an I2 gives me an I3. Is this understood? Similarly, bacha, it could have also been something like this. It could have also been like this. Then in this case, I would say an Ix which is coming is splitting into an Iy and a Iz. Have you understood? So here I will say Ix is equal to Iy plus Iz. Write one more line that this Kirchhoff's current rule is based on the law of conservation of charge. Bacha, what is current? Flow of charges. If your current charges are flowing from here and charges are flowing from here, you can't accumulate charge at a junction. Whatever has come has to pass out. Is this understood? Law of conservation of charge. So at any junction, sum of the current entering should be equal to sum of the current leaving. This is known as KCL or Kirchhoff's current rule, also known as junction rule. With two rules, we will be solving some circuits today. Is this clear? Okay. Let's see the next rule. The next rule is known as the loop rule, also known as KVL, the Kirchhoff's voltage rule. So please understand this. The algebraic sum of change in voltage in a loop is 0. Algebraic sum of change in voltage in a loop is 0. Algebraic sum of change in voltage, or many people will also use the word potential. Potential is a better word. Change if potential is 0. We will not use the word voltage, children. There's a reason for that. Potential, because this law is based on the law of conservation of energy, change in potential. And this law is what you need to understand. This is based on law of conservation of energy. Achha, what does the law of conservation of energy say? Energy can neither be created nor be destroyed. It can only be converted from one form to another. From right hand, you could draw that on your left wrist. Yes, great. So that's called law of conservation of energy. Energy can neither be created nor be destroyed. Can I use the English word that energy can neither be gained nor be lost? If somebody gains energy, so I can say that the algebraic sum of net gain and loss should be 0. Can I say the algebraic sum of net change should be 0? So similarly here also I am saying the algebraic sum of net change in potential, means in other words I say that in a loop, the sigma delta V should be equal to 0. Sigma delta V should be equal to 0. In other sense, I can say potential gain should be equal to potential lost. Only then there is no change. Do you agree? You gained 5 rupees, you lost 5 rupees. Is there a gain in the money that you hold? No. You gained 2 rupees, you lost 3 rupees. Then there is a change in the money that you hold. That is not applicable here. So remember, Kirchhoff's, and this law, typically children find this only as difficult. Kirchhoff's current law is also known as the junction law or the junction rule, and this is known as the loop rule or the loop law is known as KVL. At any loop, the algebraic sum of the potential is always equal to 0. That means in a loop, potential gain should be equal to potential lost. Now let us understand what this means and what happens in a loop. This is where it gets interesting. Okay, so let's do. Okay, so let's create one loop. Let's create one loop. So let's say, I'll just check one thing and it doesn't allow me. Okay, so let me take freehand. Okay, leave it. Let me create one loop. There's a loop. B. This is a loop. So some of the things that you should remember here. Okay. One is the choice of loop. The choice of loop. You can choose any loop as long as it is a loop. Do you understand what I'm trying to say here? Is when you get a circuit, you might get a loop like this also. You might get a loop like this also. And let's name this as, say, M and N. Right, children? So a loop can be, start from a node B, B, C, N, M. It cannot be B, C, M. No, this thing. So your choice is a loop can be chosen in clockwise manner. A loop can be chosen as anti-clockwise manner. You can write it. Choice of loop, up to you. CCW, CW, your wish. Clockwise or anti-clockwise, will take you some problem. Okay. Your choice of loop can be clockwise or anti-clockwise. Okay. Have we understood this? Now our loop may contain, components. Usually these components are, you can have a resistor, you can have a capacitor, or you can have an EMF source. In grade 12, we will usually have this and this. Resistors and EMF sources. Have you understood? Right? Now tell me, children, this resistor or this EMF would be on any, and in electrical circuits, we don't see the loop as circular. Although the shape is circular, you always see it like a rectangle. Okay? Easy language mein. The cell or the resistor will be on any one of the arm of that rectangle or square. Usually they will be rectangles. Do you agree or not? So let me make one, what do you call, an arm. This is an arm, and in this arm I have created a resistor. This is a part of one loop, one arm. Clear? Now the resistor's value is R, and say a current I is flowing through it. Clear? During this process, before, so this is a part of a loop, so you must have already selected the way you will be traversing your loop, clockwise or anti-clockwise. Agreed? So let me select this. Let me select and make a copy out of it. Okay, right, fine. So your traversal can be in this direction. Your traversal can be in this direction. Let me put the arrows here. This is the way you are moving. The way you are moving. Understood? Okay. If you are moving in this direction, and the current is going in this direction, current, a lot of current is coming along with it. No, ऐसे ही आदमी देखने का positive. A lot of current is coming along with you and you are moving along. You suddenly find resistance. Acha, what does the Kirchhoff's rule talk about? Voltage, potential, only potential. So end of the day, we're going to measure everything in terms of potential. Junction rule tells us all about current. So I am moving. There's a current along with me. That means some voltage I am carrying along with me. Suddenly I find that there is a resistance. A resistance will create a potential drop. Do you agree or not? A resistance will create a potential drop. Once you cross this resistance, why do we give resistance? There is a battery which has got much more voltage. The bulb cannot bear it. So you put a resistance. You are reducing the voltage on this side. You are reducing the voltage. So if you see the EMF on this side, the EMF will be more, the voltage will be more, the voltage will be less. So when you are moving along the direction, you are actually moving from higher potential to lower potential. Do you agree? In this case, the delta V will be taken as negative because the delta V is reducing. Look at me. I have some parental V with me and I am doing an algebraic sum. If I add more delta V, my parental property increases. But actually on this side, it has to reduce. So think from the perspective of algebraic sum. I came with parental property of 5 rupees, 75 paisa, depression is there. So what will I write? 5 plus minus 0.75. I exit with how much? 4.25. Is this understood? So when you see a loop, you always remember higher potential to lower potential, there is always a drop and therefore the delta V will be taken as negative. अब मान के चलो आपका पूरा correct answer आएगा. Delta V will be always taken as negative. Have you understood? Because there is a drop in potential. Drop means whatever you are coming with, there is a drop in that value. You now no more carry that much value with you. Is this clear? Okay. But try to look from this side. Try to look from this side. The same diagram. The same diagram. So if it was 5 volts here, it has become say 3 volt here. You are coming from 3 volt. And you find that there is a higher potential on this side. So I came with 3 rupees. I add the 0.5. I exit with 3.5. So in this case, my delta V will always be positive, and these delta V's are equal to IR. This delta V is equal to negative of IR. Have you understood? This will always be positive. From here to here. So some people remember it this way. Look, if you are traveling along the current's direction, all the drops are negative. If the current is opposing you to your chosen path, then that drop will be taken as positive. You're coming from a poor side. You gained and you're moving this side. Okay? Okay. Similarly, we can also encounter a cell. And when we have our cell, we can have 2 types of movements, right? Another would be something like this. This is my cell and my movement is like this, which means my movement is this way. Now look yourself. This is higher potential, this is lower potential. You are moving from higher to lower. So here, let's say the EMF of the cell is E. So what will you consider? Negative E, because it reduces as you are going. Battery khali ho raha hai. And if you look from this side, lower to higher, it will be considered as plus E. So one thing, what did we learn? We learned loop, choose the way you want. Choose the way you want. Remember, voltage gain and voltage lost, or potential gained or potential lost. If current travels along with me and I find the resistor in the same way, there will be a drop. Potential drop will be taken as negative, because end of the day I'm going to do an algebraic sum. And if I find that the current is opposing me, that means there is a potential gain. If I'm moving along the direction of the cell, means it's simple. HP to LP, any HP to LP, there is always negative potential. LP to HP, positive potential drop. Is this much understood? Okay. Another thing that comes up is that current can be drawn from any cell. What do I mean by this is, suppose you are given a loop where there are more than one cell. We'll see some examples. You can draw and they do not show you any current. They don't show you any current direction. Like in NCERT example, if you see current direction is given, they've not shown you current direction. You can pull out the current, your choice, from any cell. Just remember that when you're doing all this, follow KCL, Kirchhoff's current rule. Whenever at junctions, that's all. Pull out current, draw out current from any cell. Right? Acha, children. Sometimes, say our student A started traversing the loop anti-clockwise, and student B for the same problem is doing with the loop clockwise. Nothing wrong. And while doing so, you all chose the same direction of current. That is not possible. Means in your clockwise, the current is moving your clockwise way. He is going anti-clockwise. He has also chosen the current as clockwise only. Right? One of you will get a negative answer. Negative answer. Okay. And the negative answer stands for nothing wrong. That the direction that you chose was wrong, but the values are correct. You might get 3 ampere, he may get minus 3 ampere. Current can never be negative, so he needs to just put a remark that the chosen direction was opposite to the actual flow of current, hence the current I1 is equal to so and so. Clear? Okay. So let's say we have a simple circuit like this, very simple circuit. I am shown that this is 10 volts, okay, 10 volt, and let's say this is 3 ohm and this is 2 ohm. They're asking us, see how much we can actually confuse you. Find the current through each of the resistor. This is actually grade 10 problem. This is a series connection. There cannot be any question of current through, or this is the same current that is running. Have I given you any currents direction out here? No, we have not given. So we'll deliberately solve it in a wrong way also. So let's say there is a current I which is moving. Okay. Now you will say, sir, how did you draw the current? Children, I have drawn the current typically from, there is one cell. So I will be an idiot if I draw out the current from here. I'll draw it out from the high potential side. And then the current is going like water. It hits this corner. Any other direction? No, sir. It goes this way. Any other direction? No, sir. Then hits here. Then here. Then here. Then here. Then here. Oh, sir. It is the same current. It did not find any any junction from where it could change its value. So we have understood one thing, that the current is I in this circuit. Right? And if you are in grade 10, what will you do? 3 and 2 combine together to give you 5 ohms. Voltage is 10 ohms. So the current is equal to V by I is equal to R. So V by R 10 by 5. So there should be a 2 ampere current running in this circuit. That was to grade 10 in which you are using series parallel. But we will use what? We will use Kirchhoff's law. Okay. So let's put Kirchhoff's law and put a loop name to this. A, B, C, D. Achha, you tell me. How should we move in the loop? You tell me. Clock or anti-clock? You tell me. Clockwise you want to move? No, we'll move anti-clockwise. Clockwise it becomes easy. Let's go anti-clockwise. Idiot approach, but still we will do. Okay. So we are doing Consider loop. So how is your loop now? Your loop is anti-clockwise, huh, children? So your loop is A, D, C, B, A. Remember, the first and the last should match. A, D, C, B, A. Fine. Shall we start? Okay. Now look at how you are moving. I'm just drawing for your simplicity. You're moving this way, right? Let's start from BA. At BA, is the current opposing me? Yes. That means if I move from here to here, should I gain potential? Yes, I should gain potential. So how much is the potential I am gaining on this side? 2I. I into 2 ohms is 2I. Do you agree? Fine. Then let me come to AD. AD, how I am moving? Look, I am moving this way. Is the current still opposing me? Yes. So I'm going to the higher potential side. How much is my higher potential? 3I. Agreed? Then I come to DC. In DC, look at DC, what is happening? At DC, I am finding that I am moving from this direction and my EMF, now there is no resistor. I am only having a cell. Here current has nothing to do. I'll just see in my movement, I'm moving from high to low. Potential is reducing. So I have a negative 10 out here. All are volts, huh? All are volt. This is IR volt, this is volt, this is also volt. Clear, Arjun? Okay. And then I go to CB. CB, there is nothing. No resistor. 0. Right? So did I end exactly at the same place where I started? Yes. And this should be equal to 0. Right? If I do the sigma, this should be equal to 0. So let's do the sigma. Okay, let's do the sigma. So how much is the sigma now? 5I minus 10 is equal to 0. 5I is equal to 10. I equal to 2 ampere. So the current running through each resistor is how much? 2 ampere. Right, children? Let's also do it now in this manner. So what is the, and we'll do it here. So consider the loop. Let's take the loop. What loop are we taking now? We are taking A, B, C, D, A. Clear, bacha? So let's look at AB. If I now look at AB, I am traversing in this direction. Current is also going. My potential is falling down. So I have a negative 2I. Then I come to what? BC. There is no drop. It's the same. Don't take I, huh, beta. All is with voltage. Okay. Then I come here. That is CD. And I'm moving from low potential to high potential. So it is a plus 10. And then I move DA. Have I ended where I started with? Absolutely. And I'm moving along the direction of current. Negative 3I. This sigma should be equal to 0. So it's negative 5I plus 10 is equal to 0, or negative 5I is equal to negative 10, or this gone. Clear? Let's get one step deeper. That will make it interesting. Any questions at this stage you want to ask, you can ask. Any questions? Keep one thing in mind. This was a simple circuit where we created potential drops. Don't go by the question solving. See what was there and what was missing in this. This question has only potential drops. This question did not witness any current getting splitted. Right? So we will see current splits are the one where two equations will be created. Two simultaneous equations will be created. So we'll see one more example now where we will bring two cells in the same loop. Single loop, double cell. Ready? Because these values match, therefore they make it easier to understand. Chalo, So let's make our circuit. Okay. Two two one one. 2 ohms, 2 ohms, 1 ohm, 1 ohm. ठीक है? And 4 volt, 10 volt. 4 volt, 10 volt. Right, children. What all do you see in this circuit? Sir, I see 4 resistors and 2 cells. How many loops can you see in this circuit? 1 loop. Can water get out anywhere? No. So is it the same water that is circling? That means it is the same current which is circling. Now question arises, sir, from which cell should I draw out the current? From which cell? What did I tell you? Your choice. Your choice. Usually we think that the higher cell with the higher EMF will have a higher current coming out of it. We don't know. So shall we draw current from this side? Let us draw current from here. Right? Water is going pluck, 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 pluck. So this is how water is moving. They have asked me find the current through each resistor. Your first answer should be the current through each resistor will be the same, because ultimately the circuit is a series circuit. Correct? Shall we name it? A, B, C, D. Tell me, Arjun, which loop? Clock, anti-clock? How do you want to go? Clockwise. So Arjun has chosen to go clockwise. So we say consider loop A, B, C, D, A. You start and you end exactly where you have started with. Okay? So let's write our branches where all things are going to happen. We have a AB, we have a BC, then we have a CD, and we have a DA. Are we ending? Let's go by AB. Okay. So how is our boy traversing? Our boy is traversing in this direction. Righto? This is how you're moving. Are you moving along with the current? Your chosen direction of current? Yes. Current can never be negative, huh? So if you get negative, that means you have chosen wrong direction of current. But the problem is not wrong. So we are moving, current is moving with us. So every drop will be a negative drop. Okay. So on AB, my drop is how much, beta? My drop is only I. I into 1 is I. And it will be minus I. On BC, as I am coming, I get a minus 2I drop here, a minus 2I drop here. And then I have a potential no higher to lower, negative 10. You can't do that, negative 10. Higher to lower, you're losing down, you're draining. Right? Then if you come to CD, what do you have? In CD, we have a negative I. Okay? And then when you're coming to DA, Zoe, now you have a build-up of plus 4 and you have a drop of how much? Minus 2I. And Kirchhoff's, all this sigma should be 0. Right? So let's do negative 1, 2, negative 3, negative 4, and this is negative 6. Negative 6I, negative 10 and positive 4. How much is it? Negative 6 is equal to 0. So 6I plus 6 is equal to 0. So 6I is equal to negative 6. I is equal to negative 1. That means the current through each resistor, current through each resistor is 1 ampere. This negative is coming because our chosen direction is opposite to the actual flow of current in the loop. So current should actually be flowing in the loop in what direction? This direction. You will be given full marks, nothing wrong. Because if you apply common sense also, a higher potential source will a symmetric type of circuit, not 2 2 1 1. So what gave you the right to do this? We actually went foolish, and by going foolish we learned that your answer is coming. So you may get a negative. Current cannot be negative. Any negative current tells you that in a simple circuit, if you're getting negative current, that means your chosen direction is wrong. Makes it easy now. Now we need to have loop inside loop, which is the interesting one. Shall we? Then you can solve that NCERT wala problem also. Chalo, let's solve a loop inside loop problem. So we have ten ohm, 10 ohm, 10 ohm. 10 ohm, 10 ohm, 10 ohm. Find the current through each of the resistor. Okay? So first let us name the loops A, B, C, D, E, F. Okay. So we need to now give our currents. Now your wish, you can draw the current from any of the cell that is of your interest. So both are 20 volts. So let's start drawing the current. Let's say we give a current direction here. This current is going in this direction. So obviously the current has to split. Yes or no? We have to apply Kirchhoff's law. Acha. Another thing I could have done here is, we could have done this one also. Look, we could have said that current is coming out from here also. Draw from any of the cells that you are finding. It is coming out from here, right? And this current is coming up till here. And then both are combining and entering here. And again here it is splitting away in this. And here it is splitting away in this. Your choice, whichever way you want. Which one? This is symmetric. So I'm saying current is coming out from this cell. Current. You draw the way you want. Just at the junction, obey the law. We'll see different combination. What did I obey in this law? That in this junction, this current is coming to this junction. This current is coming to this junction. Water is coming from both sides. Now water can flow only through. Entering the junction should be leaving. Look here. Entering the junction should be leaving. Kirchhoff's law at a junction should be satisfied by your diagram. Let's change this. Okay, let's change this. Say you want to say that this current is going here and the current is splitting in this manner. Is it obeying the junction law? Yes, it is obeying the junction law. No problem. Then what do I have to do? A small change I have to do here is that I join this and the same current is coming here. The same current is coming here. And the same current is coming here. Both the currents are joining and again going in this. This is also correct. Tell me which way you want to do. Your choice. You want to solve in this way? Right, we'll solve in this way. Okay. So let's give names Say a current I1 is moving out from here. This is I1, and I1 has split into what? I1 has split into, now see, don't bring three variables. It will make your life more miserable. So if you say that this is I2, then this should be how much? I1 minus I2. Now, the difference. If you would have gone by the first one, this minus would have been plus. Just that your calculation little bit becomes easy, but no ways, we'll go by this. Are we obeying Kirchhoff's law? We are. How we are obeying Kirchhoff's law? I1 has come split to I2. So this is I1 minus I2. So what is this current, beta? This current is also I1 minus I2. Do you agree? This current is I2. This current is I2. So I1 minus I2 and I2, I2 minus cut, this becomes I1. Have you clear as per Kirchhoff? Now tell me, which loop and what way you want to go? Your choice. Yes. Joy madam, you have never selected. You select now. Which loop? Left first? Left first? Okay, that loop selected. Traversing, clock or anti-clock? Clockwise. So she has selected this and traversing this, right? So we say, considering loop ACFA, ABCFA, ABCFA, ABCFA. ठीक है बच्चा? Shall we? चलो. So you're moving. Is current moving along with you? Yes, sir. Current is moving all along with me. Therefore, every drop is negative for me. Okay. So we start with AB. Something will happen at AB. Something will happen at BC. AB, BC, and CF. CF may two events will be happening, and then FA. Are we ending at the same place? Yes, we are ending at AB. Chalo bacha, tell me at AB, how are you going? You are having a positive drop of 20, a positive 20, lower potential to high potential. Then what is happening at BC? BC, I have a negative 10 I1. Agreed? Then what is happening at CF? CF, I have a negative I1 minus I2, which is the current 10. Clear? Negative. Then I have a negative 10 volts also. And here I have only I1. Here it is only I1. So no drop on AF. FA is 0. Alright? So this should be 0. This sigma should be 0. So let's add up beta. Plus 20 and minus 10 gives me 10. Okay? 10 I1 minus 10 I1 minus 10 I1. Agreed? Minus 20 I1. And this is how much? Plus 10 I2. Is this what you have got? Can we take out the 1 minus 2 I1 plus I2 is equal to 0. So we can say I2. So from here we get I2 minus 2 I1, I2. Okay, let's keep it like this. It will make it more better. So we will have 2 I1 minus I2 is equal to 1. Check whether you have got this equation or not. All of you. 2 I1 minus I2 is equal to 1. Did you get it? All of you. Don't copy what I am writing. Huh? I can be wrong also. So just check whether you are also correct or not. Which one? 20 and 10 makes it 10. Okay. Minus 10, minus 10. Okay. I think it's correct. Okay. Now we consider the other loop. considering loop. Which loop do you want to consider? Tell me. C, D, E, F, C, D, E, F, C. C, D, E, F, C. How should we move here? Shall we move anti-clock here? Make it complicated a little bit. Yeah, let's move anti-clock. We're moving anti-clock. C, D. Okay. So, oh, then this naming is not correct. Yeah. So we have to change our naming. Let's change our name. Our name would be C, F, E, D, C. C, F, E, D, C. C, F, E, D, C. So we would have CF as one branch, a line. Then we have FE. Then we have ED. And then we have DC. We started and ended at. Chalo, CF. C to F. C to F. Current is going along with me. Current is going along with me. So these are negative drops. Okay. So I would have a drop of negative I1 minus I2 10. Clear? Then I have a negative 10 volts here. Paka? Okay. Then I am going in this direction. Now the current has changed to I2. Okay. And I come here. So at FE I have a 0. Then at EF I have a ED. I have a plus 20. And here current is opposing me. So I have a plus 10 I2. And all these sigma should be equal to 0. So let's take it. Positive 20 and this gives me 10 minus I1. Sorry. So this is a minus 10 I1 plus 10 I2 plus 10 I2. So plus 20 I2 is equal to 0. देखो तो बच्चा. So this gives me a 1 minus I1 plus 2 I2 is equal to 0. Right? So I have my equation in this term can be written as I1 minus 2 I2 is equal to 1. See, I1 minus 2 I2. So this is I1 minus 2 let's not clumsify here. Let's solve it separately. Come. So I have 2I1 minus I2 is equal to 1. I have I1 minus 2I2 is equal to 1. Please cross multiply. So I multiply this with 2. So this becomes 4I1 minus 2I2 is equal to 2. And I2, 2. So I multiply this with 1. I1 minus 2I2 is equal to 2. And then you multiply it with a minus 1. Sorry. No, on this side it will be 1. Yeah. And then you multiply it with a minus. So this becomes minus plus minus. Right? I multiply. Now we add them. So this cancels. I get how much? 3I1 is equal to 1. So I1's value is 1/3 ampere. Pakka? So now put in any equation. Let's put in this equation. 1/3 minus 2I2 is equal to 1, or is equal to 1, or we have 1/3 minus 1 is equal to 2I2. 1/3 minus, so if you take it that side, it becomes 1/3 minus 1. So it becomes how much? 3. So negative 2/3 is equal to 2I2. So 2 and 2 cancels. I2's value has come negative 1/3. So what went wrong? The direction of I2 has gone wrong. So I2's direction should be actually in this way. Okay. So the direction of I2 should be opposite, and both the EMFs then drive and they enter on this side. Now apply common sense. Look, Zoe. I1 came out of here, I1 came out of here, they became I1 plus I2 and came out of here. The diagram would have looked better. Don't you agree? But there is nothing wrong. This is what is this is what you are learning. I1 would have come out from here, I2 would have come out from here, both would have combined and flown through here, and then again come out from here. This fellow would have gone here. So next time you see this, keep that in mind so that your answer comes correct at the first go. Clear? Okay. No. If you get a wrong sign, you just write that the negative sign indicates that our chosen direction for I2 is opposite to the actual flow of I2. Hence, I2's value has been corrected to 1/3 ampere. That's all you have to write. Okay. Shall we see that NCRT? Arjun, can you give me your book? Just see that. No, there's a diagram here also. I'll just draw that diagram. Actually, not this one. That's Wheatstone Bridge. If you have understood this, Wheatstone Bridge in one go we can do. Okay, let's see this. Now NCRT has actually made it easy for you, but we will go our way. We'll think that as if direction of current is not given. (30 ohm, 41 ohm. (4580). 10 ohms. A, B, C, D. A, B, C, D, D, then E, F, E, and then there is a F, okay, and F, and then there is a G, and then there is a H. Which one? On the right side? Yeah, 20 ohms. Okay. So these are how they have named it. Interesting, no? This is nice. So tell me, let's take one loop. Which one? A, H, D, C, B, A. That means we are moving this way. Clear? Okay. How do you want the current to come out? Current's direction. Let's say we have a current I1 flowing from here, right? And I1 splits to, what is the current out here? Let's say this is I2, this is I1 minus I2. NCRT has put a I3 also. Reduce the variables. If you reduce, it becomes easy. Okay? Then what current is flowing here? I1 minus I2. Clear? And I1 current is flowing here. I1 has got splitted to I2, I1 minus I2. Then the same current has come here. I1 minus I2. And how does the current look like now? In this direction, I1 has come. In this direction, I1 has come. So what should come here? You only check. Say this is x plus I1 minus I2. X plus I1 should be equal to I1. So I1 and I1 cancel. So x should be equal to I2. But I2's direction will be what? How can the same I2 hit with both? If I put I2 out here, so I can put straight away I2 out here. Just see, as per Kirchhoff's law, am I obeying? I2 plus minus I2 plus I1. I'm obeying. Don't put I2 in this direction. Huh? Two currents cannot collide. Same current. Job is done. Let's see in this row. We have, what all we have? We have AH, HD, CB, BA. Chal, AH. A to H. A to H is what? You're moving against the current. So you have a positive build-up. So it would be 30 times of I1 minus I2. Do you agree? Okay, good. Then you come from H to D. H to D, we have nothing. 0. Then you come from D to O. D to C. My mistake. Then we have a D to C, C to B, B to A. Okay, D to C. D to C. I have a positive build-up here of 45. Right? Then C to B. I am moving along the direction of the current. So it is a negative I2. Negative I2. Then I am moving along the current. So it's a negative 40. Negative 40 I2. Do you agree, bacha? And then we're done. This sigma should be equal to 0. So add up. I think you have learned now how to do. Okay? Achha, see, every time you need not have only this one and this one. You would have taken the external one also. Nothing stops you. Which one are you taking? Next loop? Okay, you want to solve this? Just keep the equation ready. So we have a 30 I1 and rest are all I2. So I have a 30 I1. Then I have a minus 30 I2, minus 40 I2, which is minus 70 I2, minus I2, minus 71, minus 71 I2 plus 45 is equal to 0. Children, did you get this or not? 30 I1, minus 30 I2, minus 40 I2, minus 70 I2. Correct? Okay, next we take a loop. Next loop would be A, G, F, E, D, C, B, A. I am complicating it as much as I can. And you're moving this way now. Okay? So AG, GF, FE, ED, DC, CB, BA. Come on. AG, A to G, 0. No potential drop. G to F, I have a buildup of positive 80. F to E, current with me. So that's a negative 10 I1. E to D, current along with me, negative 20 I1. Then D to C, I have a push of 45. And then C to B, the current is with me. So I have a negative I2, means I2 multiplied by 1 is I2. And then here also, look, the current is going this way. So I have a negative 40 I2. All these sigma should be equal to 0. So let's catch up. 80 plus 45 will give me how much? 125. So 125 minus 10 I1, I retain it. And then I have 20. Oh, minus 10 and minus 20. That makes it minus 30. Minus 30 I1. Fine, I've got a I2 and a minus 40 I2. So I have a minus 41 I2 is equal to 0. These are the two equations. Did you get it? Did it tally? So you can solve it. Okay. So one more class we will do on Wheatstone bridge, and next class itself we'll pick some problems. Wheatstone bridge, some problems, and then current electricity gone. We move to magnetism. You can solve this. Not a big issue. This is not a problem. In problems, generally they'll give you ones which tally. Okay.